Hello and welcome back to my YouTube channel or the VIG Structure Hub. This is a place where you learn, build and innovate. Today I want to tackle example number 1 under retaining walls, and the question is on the board. The question reads, check the stability of a cantilever retaining wall which is required to support a bank of earth 4 meters high above ground level. Assume a self-bearing capacity of soil to be 160 kilonewton per meter cubic. Angle of internal friction of soil is 30 degree. Coefficient of friction between concrete and soil is 0.6 and density of concrete is 2400 kilogram per meter cubic. So as you can see, this is the retaining wall. The stem of this retaining wall is 4 meters high, and the top width of the retaining wall is 200 millimeter, and the bottom width is 300 millimeter. The width of the toe is 810 millimeter, and the width of the heel is 1560 millimeter, and the thickness of the base is 450 millimeter, and the distance between the base and the ground level is 1.25 meters. So this is the ground level and this is the backfill. So ground level. So let's see how we can tackle such a question. So the first thing to do is to identify information that will help us to check the stability of this dam. And one of the information is the force which is exerted on this retaining wall. So this force is the active pressure, and if we can draw the diagram of this active pressure, so it will look like this. So this is the diagram for the active pressure. Remember, the active pressure is acting from the bottom to the top of this retaining wall. So let's draw the pressure diagram for this soil. So this is the pressure diagram, and this pressure is the active pressure. So let's assume it is acting at that point. So it's the active pressure PA, like that, and it is acting at a distance of h/3 from the bottom or from the base. So PA is acting at a distance of h/3 from the base. So this is the distance. So h/3. Again, we have the downward pressure as a result of the backfill. So this backfill, it is causing a downward pressure. If you can draw the pressure diagram, so this will be the pressure from the backfill. Like that. Again, we have another pressure from this side, and this pressure is the passive pressure, And if you can draw the diagram, this is how it will look like. So that is the passive pressure. And this passive pressure, it is acting in this direction. So this is the passive pressure. And remember, this distance from here to here is 1.25 meters. So 1.25 meters. Like that. Again, we have another pressure from the ground. The pressure from the ground, if we can draw this pressure from the ground, so here we will have the maximum pressure and here the minimum pressure. So this pressure from the ground is acting upward. Like that. So this is the P maximum. And this is the P minimum. Remember, this P minimum must be greater than 0. And this one must be less than soil safe bearing capacity of the soil. Like that. So after identifying this important information, then we can start solving this question. So allow me to clean here so that I can create more space for more calculation. So to check the stability of this retaining wall, we will consider the three items, which is number one, we have the overturning of the retaining wall. So number one is overturning. Number two, we have the sliding. And number three, we have the bearing capacity. So those are the three important items to check on this retaining wall. So I will begin by overturning. So number one is overturning. We know that this active pressure, as a result of this retained soil, can cause this retaining wall to overturn at point A. And let's say this is point B. So if this retaining wall is not stable enough, then it will overturn at this point. So for overturning, we'll check factor of safety. Factor of safety of overturning. And this one is given by resisting moment, resisting divided by overturning moment, and the factor of safety of overturning, it should be greater than or equal to 1.5. So if it will be less than 1.5, then it means overturning will occur. So we will start by calculating the overturning moment and the resisting moment. So I will begin by overturning moment. So overturning moment is caused by this active pressure. This is the active pressure as a result of the retained soil, and we are supposed to calculate this active pressure, which is PA. So PA is calculated using this formula, W H square over 2 1 minus sine over 1 plus sine, like that. So this PA is the force which will cause this dam, no, this retaining wall to overturn. So let's proceed. So PA is equal to W is the weight of the soil, and H is the height of retained soil, which is the height from here to the top, from the bottom to the top of the retaining wall. So it's equal to the unit weight of the soil is 18 kilonewton per meter cubic. So this is W, which is 18 times H. H is this distance from here to here. And since you have not been given, you will take this distance from here to the ground level, which is 1.25. Then you add from ground level to the top of retaining wall, which is 4 meters. So it will be 4 meters plus 1.25, which is 5.25. And then you square over 2 into bracket 1 minus sine. So this is the angle of internal friction of the soil, which is 30 degree from the equation, sine 30 degree over 1 plus sine 30 degree, like that. Again, something you should know, about this pressure as a result of the retained soil, this base is given by this distance is given by Ka times density times H. So Ka is the Rankine's coefficient of earth pressure, and this is the unit weight of the soil, which is 18, and H is this distance from here to here. So if you continue, you know that the formula for getting this, the area of this shape, is a half base times height. So if you can proceed, you will end up to this formula. So if you punch your calculator, you will get PA as, therefore PA is equal to 82.69 kilonewton. 82.69 kilonewton. So that is the active pressure of this retained soil. And the overturning moment is as a result of overturning moment is equal to the horizontal force is equal to horizontal force which is PA times perpendicular distance. So this is the force PA, and the perpendicular distance is from here to here, which is h over 3. So overturning moment is equal to 82.69 times h over 3. So which is equal to, let me write the formula first. Overturning moment is equal to PA times h over 3. So PA we have calculated and is 82.69 times h over 3. The distance from here to the bottom is 5.25 over 3. So if you punch your calculator, you will get 144.70 kilonewton meter. So this is the overturning moment. We now proceed to another moment, which is the resisting moment. So I will erase here again. So the resisting moment is the moment due to vertical forces. Summation of moment due to vertical forces. And vertical forces will be the forces, or will be the force of this retaining wall and the force of this backfill. So that one will be the moment due to vertical forces. So for us to calculate the forces due to this retaining wall, we will subdivide this retaining wall into various shapes as follows. As you can see, this is a trapezium and this is a rectangle. So for this trapezium, I can divide it into two like that, so that I end up having a rectangle, which is number 1, and a triangle, number 2, and also a rectangle, number 3, like that. So we will calculate the force as a result of this area, which is number 1, and then the force as a result of this area, number 2, and then area number 3. Having done so, we will have calculated the area of this retaining wall. And then we will also add the area as a result, not the force, as a result of this area caused by this backfill. So let's begin by number 1. And remember, this is the stem. This is the stem and this is the base. And the base is divided into a toy. So from here is a toy. And from here to this side is a hill. So I will start by area number 1. Let's say stem 1. So area of stem 1. No, force, not area, force of stem 1. So the force of stem 1 will be the area of this rectangle, which is 0.2. You change it from millimeter to meters by dividing 200 by 1000. So 0.2 times the length is from here to here. So it means you will take 4 plus 1.5 and then you subtract 0.45. So this is 4. From here to here is 4. And then from here to here is 4. Then you add from here to here, which is 1.25. So you will get 5.25. And then you subtract 0.45. So this is 4 plus 1.25. Then you will get 5.25. And then you minus from here to here so that you can get this distance from here to here, which is 0.45. So this is 0 is 8. So it is 4.8 times 4.8 times 4.8 times the unit weight of this concrete retaining wall is 24 kilogram per meter cubic. So you take 24 times gravitational acceleration, which is 9.81, then over 1,000. So you take the density times gravitational acceleration. By doing so, you will get the force in Newton. No, you will get the unit weight in Newton per meter cubic. Then you divide by 1,000. You will get the unit weight in kilo Newton per meter cubic. So it means the answer is equal to, so if you punch your calculator, you will get 23.04 kilonewton. We proceed to force of stem 2. So forces of stem 2, it will be a half base times height. So the base is this distance from here to here. Remember, from here to here is 300, and then from here to here is 200. So this distance will be 100, like that. So times 0.1, we are converting to meters, then times h, or length, which is 4.8, times the unit weight of concrete. If you convert this, you will get 24 kilonewton per meter cubic. So if you punch your calculator, you will get 5.76 kilonewton. Then we proceed to the force of this base. So force of the base. So this one is equal to length times width. So the length is 810 plus 300 plus 1560, and then you convert it to meters. So you will get 2.67 times the thickness is 450, which is 0.45, and then times the density or the unit weight of concrete, which we have converted, and it is 24 kilonewton per meter cubic, which is equal to, the answer is 28.84 kilonewton. After calculating the force of this base, we'll also calculate the force as a result of this backfill on the retaining wall. So the force of backfill is given by the area of this, is given by the area of this times the unit weight of soil. So the area of this rectangle, which will be length times width. So the width is 1560, which is 1.560, then times the height, or the length is from here to here, which is 4.8 times 4.8 times the unit weight of the soil, which is 18 kilonewton per meter cubic. So times 18, then you will get 134.78 kilonewton. After doing so, you will get the summation of the vertical forces. So summation of vertical forces, which is equal to the summation of all the downward forces. So you will add 23.04 plus 5.76 plus 28.84 plus 134.78, and you will get 192.38 kilonewton. So that is the total force, the total vertical forces, which is 192.38 kilonewton. So after doing so, now we proceed to moment due to vertical forces. And this is how we do it. So we are now going to calculate the resisting moment, which is moment due to vertical forces. So we will consider the moment about point A, about point A. So this point A is the point where the overturning will occur. So if we start with our force, which was as a result of force of stem 1, the force of stem 1 was 23.04. So we will multiply by the distance from point A to a half of this rectangle. So that one, it means you will take this distance so that is 810. If you convert it to meters, it will be 0.81. So times the perpendicular distance, which is 0.81 plus 100, you convert it to meters, which is 0.1, and then plus 0.2 over 2. So this is the distance from point A to the middle of this rectangle. And you will get your answer as so the answer is 23.27 kilonewton meter. 23.27. We proceed to force as a result of this shape, which was force of stem 2. So it will be the force of stem 2 was 5.76. Yes, 5.76 times the distance. So the distance is from A to the center of this triangle. So you will take, so this is 0.81, 0.81 plus, we have this triangle. So the centroid will be 2/3 times 0.1. If you punch your calculator, you will get 5.05 kilonewton meter. So that is the moment of this shape. Then we proceed to the moment of the base of this base. So remember the force so the force was 28.8, and then times the center of this distance all the way from here up to here. So you'll add 810 plus 300 plus 1560, which is 2160. So that is 2160. No, 2670. Then you divide by 2. So the answer will be 38.45 kilonewton meter. And then we will proceed to the backfill. So the force as a result of this backfill is 134.78, then times the distance. So the distance, you will add this distance from here to the center of this rectangle of the backfill. So it will be 0.81 plus 0.30 plus 1.56 over 2. So the answer will be 254.73 kilonewton meter. So having done so, we'll add all the moment. So you'll add 23.27 plus 5.05 plus 38.45 plus 254.73. So you will get moment of resistance is equal to 321.50 kilonewton meter. So that is the moment of resistance. So this one is supposed to be 2.6 because we are converting it from millimeter to meters. So this is the total moment of resistance. So let's check for overturning. So factor of safety of overturning, factor of safety of overturning is given by moment of resistance over moment of overturning. Moment of resistance over moment of overturning. So moment of resistance is equal to 321.50 over moment of overturning 144.70. So that 1.50 over 144.70 should be greater than 1.5. So let's see if it is less or greater than 1.5. So if you punch your calculator, if you carry out the operation, you will get 2.25, which is greater than 1.5. Therefore, safe against overturning. Safe against overturning. And then we check for sliding. So let's check for sliding. So Roman 2, we have sliding. So for sliding, factor of safety of sliding, factor of safety of sliding is equal to resisting force over sliding force. whereby the resisting force is given by mu on a moment times summation of vertical forces plus passive pressure over no. So this is the resisting force. So this one is the coefficient of friction between concrete and soil, which is 0.6. So M times summation of vertical forces is equal to 0.6, which is, this one is given in the question as the coefficient of friction between concrete and soil. And summation of vertical forces, we have already calculated this, and this one is 192.38, like that. And then P, so this is the passive pressure, which is on this side. So this one is given by WH square over 2 into bracket 1 plus sine over 1 minus sine. This is for the passive. And remember, we have passive and active. So active is this one. So for the active, it changes, the sign changes. So for the active, it will be 1 minus sine, and then over 1 plus sine theta, like that. So passive pressure is equal to the unit weight of soil is 18 times H. So H, it will be, H will be 0.45 from here to here. So from here, so that is 0.45, that is for 50, you convert it to meter square over 2 into bracket 1 plus sine 30 over 1 minus sine 30, like that. So if you punch your calculator, you will get 5.48 kilo Newton. So the resisting force is equal to, if you multiply this, you'll get 115.43 plus 5.48. So the answer is 120.91. And then we proceed to sliding force. So this is the sliding force. So let's proceed to sliding force. So sliding force So sliding force is given by this one is equal to horizontal component. So is equal to PA, which is equal to horizontal component. So we can now check the factor of safety for sliding. So factor of safety for sliding which is given by so this one is equal to 120.91, and remember our PA is 82.69. 82.69, and this one should be less 1 point, no, should be greater than or equal to, so this one should be greater than or equal to 1.55. So if you punch your calculator, this one you will get 1.47, 1 point, which is less than 1.55. And for the sliding not to occur, it should be greater than or equal to 1.55. So this one is not safe. Therefore, not safe for sliding. Provide shear key. So you will provide the shear key. Again, you will come and design the dimension of the shear key. And then after designing and getting the dimension of the shear key, you will get the force as a result of the area of the shear key. And then you will add to the summation of vertical forces, which is this one. And then you will multiply by this coefficient of the friction. And then you check again if there will be sliding or not. So for that, for such a case, I will do it later for you guys. For now, so today we are just checking whether the retaining wall is safe or not safe against sliding. Bearing capacity. So you have the bearing capacity. Bearing capacity. So we know that the pressure maximum or the maximum pressure is given by summation of vertical forces over B 1 plus 6 E over B, and the P minimum is given by summation of vertical forces over B 1 minus 6 E over B. So for it to be safe, for the bearing capacity, this one, it should be less than the safe bearing capacity. And this one, it should be greater than 0. So let's check. And remember, our E is the eccentricity. E is our eccentricity. So E is the eccentricity, as you can see, and is given by B over 2 minus D. So if I can take this base of this retaining wall, as you can see, and draw it here, then this will be the center of this base, such that the resultant force will cut the base at this point. So the distance between where the resultant force cut the base and the center of the base is called eccentricity. And then to get eccentricity, you take B over 2 minus D. So it means the resultant force, which is R, must be within the middle third rule. As you can see, I have divided this into B over 3, B over 3, B over 3, and it should be in between the middle third rule. So distance D is given by, so D is given by moment of resistance minus overturning moment over summation of vertical forces. Like that, you will get distance D. So moment of resistance is, so D is equals to, moment of resistance is 321.5 minus 144.70 over the summation of vertical forces is 192.38. So D is equal to 0.92. 0.92. So that is our D. So let's proceed and get our E. So E is equal to B over 2 minus D. So which is equal to, if you add 810 plus 300 plus 1560, you will get 2.670. 2.670. Then you divide by 2 minus 0.92. So you will get 0.42. So E is equal to 0.42 meters. So and then E should be less B over 6. So let's check. 0.42 should be less 2.670 over 2. So which is equal to 0.42 is less 0.45. 0.45. So therefore, the resultant is falling at middle third. At middle third of the base. Like that. Now, let's now proceed to the maximum pressure and minimum pressure. So let's calculate the maximum pressure. So P maximum is equal to summation of vertical forces over B1 plus 6E over B. So our summation of vertical forces, it remains the same, 192.38 over B. You add this, so you will get 2.67 into bracket 1 plus 6 times E. E is 0.42 over B, 2.67. So if you carry out the operation, you will get 140.06. 140.06, and which is less than our our self-bearing capacity of the soil, which is 160 kilonewton per meter square. Therefore, safe. So let's calculate the P minimum. P is equal to summation of vertical forces B minus 1. So P minimum is equal to summation of vertical forces over B, 1 minus 6E over B, like that, and then you insert the values in the equation, and then you carry out the operation. So you will get 4.05, which is greater than 0. So therefore, safe. And our question ends there. In the future, we will also carry out such a question when there is a surcharge at the top of the backfill. So maybe in my third example, I will be tackling another question, a similar question, but with a surcharge at the top of the backfill. So stay tuned for more from Overturning Structural Hub. And for those who have not subscribed to this channel, please do so and hit the notification bell so that you may be the first person to be notified when I upload a video. So thank you for your time, and we meet again in my next session.